Hey, this is Chris. Welcome back for another math video. Today, we're tackling a problem from an 8th grade local contest. It has two parts. The first one may seem simple, but it actually gives us a key insight for solving the second part. In problems like these, the first step often lays the groundwork for the next. So let's break it down and see how it all connects. Point A, this is actually the inequality of arithmetic and geometric mean. So let's do this. There are multiple ways of solving it. Let's go in this direction. We have square root of AB is less than or equal to A plus B divided by 2, which is equivalent to 2 square root of AB, which is equivalent to A minus 2 square root of AB plus B, and this needs to be greater or equal than 0. And if we look at this, we get that it's actually equivalent to square root of A minus square root of B, everything raised to the power of 2 greater than or equal to 0, which is obviously right. And we get equality if square root of A is equal to square root of B. Both numbers being greater than 0, we get that A equals to B. And in case you didn't see this part, it's actually x minus y to the power of 2, where we have taken x equal to square root of A and y equals to square root of B. Alright, now that we got the first part completed, let's see how we move to the second point. Even if it looks pretty dangerous, the second inequality, we'll have to find a way to apply point A. We have at least two ways of applying it. Now let's see what would happen if we apply the inequality like this. We take A as this first term like this, and B from our first inequality like this, because we have this 3 here below, which kind of makes us wonder what to do with it. So let's apply the first inequality to it. B, we have square root of x over 3 multiplied by y plus z. Now we apply the inequality from point A, and we get that it's less than or equal to, the first term is x over 3 plus the second term is y plus z all over 2. And this is equal to x plus 3y plus 3z over 3, or everything over 2. And this is equal to x plus 3y plus 3z, everything over 2. 3 goes here, and we have 2 multiplied by 3, it's 6. And if we do everything the same for the other two, in the same manner, we get that for this second part. And then we apply the same for this one. We get that. Square root of y over 3 multiplied by z plus x is, let's do the same, y over 3 plus z over x, everything divided by 2. In the same way, we get that it is y plus 3z plus 3x all over 6. And the third one, it is z over 3 multiplied by x plus y less than z over 3 plus x plus y, and this is z plus 3x plus 3y, everything over 6. So we get that. If we add all of them, we get that our inequality, let's call everything from here our expression E equals to, so our expression is less than or equal to this one plus this one plus this one. So we get that it's x plus 3y plus 3z over 6 plus y plus 3z plus 3x over 6 plus z plus 3x plus 3y, everything over 6, which is equal to, and now it's equal to, we can see that we have over 6, so we're good with this one. And let's count x. x 1 plus 3 plus 3. So it's 7x plus, same way we get 7y plus 7z, which is equal to 7 over 6 multiplied by x plus y plus z. And we got that it was supposed to be less than 5 over 6. And if we look at 5 over 6, is it 5 over 6 x plus y plus z? No, this is wrong. It doesn't give us that. So I just given you an example of what would happen if we've taken the wrong approach and chose x over 3 instead of choosing x as a and y plus z over 3. So if we go down and apply how we are supposed to, let's erase everything so we go in the right direction. So now we do the following thing. We take x over y plus z, everything over 3. We do the other way. We take a as x multiplied by y plus z over 3. And this time we apply the inequality for x as first term and y plus z, everything over 3, as the second term. And now we get that this is less than or equal to x, first term, plus y plus z, everything over 3. And now we do the same. We get 3x plus y plus z and everything over 6, because this 3 goes down here and it's 2 multiplied by 3 and it gives us 6. We do the same for the others. We take square root of y over z plus x, everything over 3, equals with y multiplied by z plus x over 3 less than or equal to. In the same manner, we get that it is y plus z plus x all over 3 divided by 2, which is equal to 3y plus z plus x, all of it over 6. The last one, it is z multiplied by x plus y, everything over 3. We rewrite it as z multiplied by x plus y over 3, square root of it. Apply the inequality again from point A, from point A, from point A, like I've mentioned, and we get that it's z plus x plus y over 3 divided by 2, and this gives us 3z plus x plus y over 6. And now we get that our expression, as we've mentioned here, our expression is equal to, and now we add this part that we got from our inequality. It's actually less than or equal to 3x plus y plus z over 6 plus 3y plus z plus x over 6 plus 3z plus x plus y over 6, and this is equal to, and if we count x first, we get that it's 3 plus 1 plus 1, which is 5x plus, the same manner we get y, 3 plus 3 plus 1. This is 5y plus 4z, in the same manner we get 5z, everything over 6. And this is equal to 5 divided by x multiplied by x plus y plus z. And this is our inequality. And this is what I try to show in the first try, that sometimes you need to think very thoroughly to the substitutions that you make whenever you use the existing inequality that it's either given to you or you know a way of getting something like this. So now we have proved our inequality, and that's what I was actually trying to say, which is the equality in this case. If we look at the terms where we got a, this is a, for example, and this is b. And equality is when these two are equal. But it's also applied when these two are equal, and it also applies when this is also equal. So we get that x is equal with y plus z, everything over 3. We also need to have y equals to y is equal with z plus x over 3, and z is equal with x plus y over 3. If we multiply 3 with x and 3 with y and 3 with z on the other side, we get the following three equalities. 3x equals with y plus z, 3y equals with z plus x, and 3z equals with x plus y. And we add all of them, and we get that 3x plus 3y plus 3z equals with 2x plus 2y plus 2z. If we subtract in one side and move everything for x and then for y and then for z, we get that x plus y plus z equals with 0. And because all of the three numbers are greater than 0, it means that all of them need to be equal with 0. So we get that this is x equal with y equal with z, and this is 0. But we cannot have equality because these terms are never 0. But this is what we've had in case we are looking for the case of equality. And now our inequalities are solved. If you like this video, drop it a like before you go and make sure you subscribe for more. See you soon for the next one.